In this video, we're going to look at the conversion factors that we learned about in the Introduction to Moles video, the molar mass and Avogadro's number, and we're going to learn how to use those numbers in calculations. We have two different factors. We have the molar mass, which relates the moles of a substance to the mass of a substance. And then we have Avogadro's number, which relates the number of moles of a substance to the number of things, particles, atoms, or molecules in a mole of a substance. So let's look at how those relate. If you look at the flow chart, you can see that moles are here. And if we want to move between moles and mass, we use our molar mass as the conversion factor. And we can also use that conversion factor to go from mass to moles. And then if we look at the other side, we can go from moles to particles. So we can use Avogadro's number, the number of particles in a mole, to go from moles to particles or from particles to moles. Let's look at how we do that with an example. So here's a practice problem. The problem is asking us how many carbon atoms are in 5.10 moles of carbon. So if you look at our flow chart, we've got the number of moles of carbon, 5.10, and it's asking us how many carbon atoms. So that is a particle. So we're going to use Avogadro's number to go between the number of moles of carbon and the number of particles or atoms of carbon. And so we're going to set that up. We're going to start with 5.10 moles of carbon. And we're going to set up our conversion factor. Remember that we're going to be using factor label, just like we have since the beginning of class. You're not allowed to forget anything in here. Think about the units that we want on the bottom to cancel. We want to go from moles to particles. So we need moles on the bottom to cancel. So we'll put moles of carbon. And then we want to go to the particles, which in this case is atoms. So we're going to put atoms of carbon on the top. And then if you look at your reference table, you can see that the number of particles in 1 mole of anything is 6.022 times 10 to the 23rd atoms of carbon in 1 mole. So that Avogadro's number that we use from your reference table, that is the number of atoms in 1 mole. Now you should pull out your calculator, multiply this, and make sure that you're getting the same answer. Pause the video if you need a moment to do that. And then check your answer. And you should have 3.07 times 10 to the 24th atoms of carbon. You can see that the moles cancel, and you're left with atoms as your unit. Let's look at another problem. Now we've got a problem that's asking us to go from moles. It's giving us the moles of carbon in the problem, and it's asking us to find the mass. So we're going to start here on our flow chart with the moles, and we're going to convert to mass using the molar mass as a conversion factor. So again, we're going to start with 5.10 moles of carbon, and then we are going to look up on our reference table the molar mass of carbon. You should have that out. Pause and look it up. And then we're going to set up our conversion factor. So think about your units. You want moles of carbon on the bottom to cancel, and then you want grams of carbon. That's the unit that we're trying to get to. And when you look on your reference table, the molar mass of carbon is 12.01 grams per 1 mole of carbon. So 1 mole of carbon contains 12.01 grams. And when you punch that in on your calculator, which I'm sure you're doing right now, you should get 61.3 grams of carbon. Let's look at another substance and see if we can figure out how to work that. So here's another practice problem. This problem involves water. It asks us, what is the mass of 2.50 moles of water? So we're starting with moles, and we're converting to mass. And in order to do that, our conversion factor will be our molar mass. Now, the molar mass of water is not just something we can look on our periodic table and instantly find. We're going to have to figure it out. So we know the formula for water. It is H2O. And what we need to do is add up the molar masses of each of the atoms in this molecule to figure out the molar mass of the entire thing. So we know that we have hydrogen. There are 2 atoms of hydrogen. And the molar mass of hydrogen, look it up on your reference table, is 1.008. And that's going to give us 2.016. For oxygen, we have 1 oxygen, and the molar mass of oxygen is 16.00, and that gives me a total of 16. And when I add those together, it's 18.016. That is the number of grams in 1 mole of water. So once we've added up the total number of atoms in that molecule, that gives us the molar mass of the entire compound. So let's go ahead and set this up with our factor label to convert it. We have 2.50 moles of water. We're going to set up our conversion factor. Think about your units that you need to go on the bottom. You want moles of water on the bottom to cancel. And you want grams of water on the top. And we just determined over here that 18.016 grams is the number of grams in 1 mole of water. And now you can see that moles will cancel. I'll be left with grams of H2O. And when you punch this into your calculator, you should get 45.0 grams of water. Please make sure that you're looking these things up on your reference table when I talk about the reference table, and that you're punching the numbers in on your calculator to be sure that you're getting the correct numbers, especially the ones that have the exponents, because those can be tricky. Let's try another problem now. So in this problem, it's asking us how many water molecules are in 2.50 moles of water. If we look at our flow chart, we can see that we can go from moles to particles. Molecules are one of our particles, using Avogadro's number as a conversion factor. So we're going to start with the number of moles of water that we have, 2.50 moles of water. And we're going to set up our conversion factor. And we want to look at our units again. Remember that moles of water go on the bottom. And we want to convert to molecules of water. You cannot really abbreviate molecules because otherwise it will look just like moles. So you have to write out molecules. All right? Avogadro's number, if you look on your reference table, it is the number of particles in 1 mole. So in 1 mole of water, there are 6.022 times 10 to the 23rd molecules of water. Now go ahead and punch that in on your calculator, and here's the answer you should come up with. 1.51 times 10 to the 24th molecules of water. All right? Make sure that you're checking your sig figs. Remember, the correct number of sig figs is the smallest number in the problem. You have 3 over here in your problem and 3 over here in your answer. Let's take a look at a couple more things here. Let's look at another problem. If we have our flow chart, if we know how to convert from mass to moles, and then we know how to convert from moles to particles, and vice versa, particles to moles, and then moles to mass, we can use that information to go between mass and particles. So So if you look at this problem, it's asking us, what is the mass of 1.89 times 10 to the 24th molecules of ammonia? So in the problem, we're being given molecules, which are particles. We can use our conversion factor with Avogadro's number to convert from particles to moles. Once we have the number of moles, we can use the molar mass as a conversion factor to find out the mass of ammonia. So let's set that up. So we've got 1.89 times 10 to the 24th molecules of ammonia. I hope you remember the formula for ammonia. Remember that you're not allowed to forget anything. It's NH3. And we first want to go from particles to moles, and so we're going to use Avogadro's number as our conversion factor. So we want molecules on the bottom. Remember to think about your units. You want molecules on the bottom, molecules of ammonia, and then we want to go to moles. So we're going from particles to moles. We want moles of ammonia on top. Look on your reference table. Remember that it says, Avogadro's number says that 1 mole of ammonia is equal to 6.022 times 10 to the 23rd molecules of NH3. So now molecules will cancel, and we'll have moles of NH3. Now that we have moles of NH3, we can convert to mass using the molar mass. So let's set up another factor. We're going to want moles on the bottom to cancel out. Always think about those units first. And we're trying to get to mass, so we're going to want grams on the top. Since NH3 is a compound, we're going to have to calculate the molar mass. So if we look up the molar mass of nitrogen, we have 1 nitrogen, and that's 14.01. Whoops, that should be a 1. And that's going to give us a total of 14.01. And then with hydrogen, we have 3, and they have a molar mass of 1.008, and that gives us 3.024. And if we add those together, that's going to give us a total of 17.024. And that is the number of grams of ammonia, 17.024 grams of ammonia in 1 mole. Now remember, with factor label, you multiply the things that are on the top, and then you divide by what's on the bottom. Go ahead and pause and push this into your calculator, and then determine what the answer is. And when you've punched that into your calculator, remember that you want to give the correct number of sig figs. You have 3 in your problem, so there should be 3 in your answer. You should have 53.4 grams of ammonia. Okay, your molecules have canceled, your moles will cancel, you're left with grams of ammonia. Let's try one more problem. In this problem, you're seeing a new term. It's called a formula unit. A formula unit is similar to a molecule, except that it's for ionic compounds. Remember that a molecule implies that a compound has covalent bonding, and of course ionic compounds don't have that type of bonding. So we need to use a different term for that, even though it's really similar when you think about it in terms of the formula. This says, how many formula units of calcium chloride, that's an ionic compound, are in 18.5 grams of calcium chloride?